In this Pufferfish Grasshopper tutorial, I want to show you how to model this with Twisted Box and with the Pufferfish plugin. And as you can see, it's not really complicated. We have a great component called the Twisted Box pipe variable, which we will use. But there are some techniques we will use to extract the thickness. So first of all, what I want to do is to use the Pufferfish plugin, and in the Twisted Box you can see that there is a Twisted Box pipe variable. So if I put that into the canvas, I want to explain how we can use that. So first of all, let's just put the bifocal plugin here. We need a curve to produce a pipe which is actually dividing by the pipe variable into a Twisted Box. So what I want to do is to go to the front section and draw a arc from 0, use the shift key and draw an arc like this, and I want to give that as the curve. You can also produce or model a parametric curve if you want, but I just want to make this easy. Okay, the next part is the parameters we have to fill, and also the diameters, thickness, and rotation. The first one is the U parameters, and it's the division we have. If we assume that this is a curve from 0 to 1, we want to divide that in the U direction. Okay, so what I want to do is to simply use a range, and the range is by default from 0 to 1. You can just give a step to it. So let's just give a number to the steps and give this to the parameters U. Okay, and as you can see, we have an error and says that you have to supply equal amounts of U to the diameters, thickness, and rotation. So remember, if we give 7 numbers to the U, we also have to give 7 numbers to the diameters, thickness, and rotation. So let's get started by first giving one number or one range to these 3 and then explaining the other sections. So what I want to do is to also copy this but have the same steps and define a range. So I'm going to go to the math and use a construct domain to define a minimum and the maximum. So let's just bring it here. Maybe we just need a number. We're simply going to make a range so you can see the results and understand each of these inputs. So I'm going to give this to the diameters, thickness, and rotation and explain each of them. The first one which I want to explain is the diameter, so it's really easily understood. You can see this is the minimum of the radius. If you give this as a diameter, it's going to be this as the start, and this will be the end, which is like here. Okay, so this is really easy, but let's go to the division. You can see that we are actually dividing the U parameter here from 0 to 1 to the steps. You can also control that if you want to give it a number. It's going to start from 0 to that number. You can see that we are covering the U parameter on the curve. Okay, so this is the first step. The next step is the V parameter, and as you can see here, you see it's the revolution of the pipe. So if I give this a number again, let's just bring this down and give this a number from 0. You can see it's going to be a straight one, and add this up with a shift key to another number. You can see that this is bringing the Twisted Box. Okay, so again, if you want to, let's just make this happen. You can see how easy it is to produce that rotation. So it's from 0 to 0.4, maybe 0.8. You can see it's exactly covering that pipe. So what can we do here is again copy this if we want to and give it a different step. Maybe we just want to divide this to 4, and it has to be from 0 to 1. So I'm going to disconnect this, and you can see the range is from 0 to 1. We have a tutorial about range. If you have not watched it, I will put it up here. Just watch the tutorial, you can understand what you can do also with range. So I'm going to give that to the V, and this is actually the sections you can see how many section 3, 4, 5, 6 you can make on this pipe. So that was the V parameters. Then we need this W, which is the thickness. Okay, so if you give this a number between 0 and 1, and here you go, you can see that there's a thickness. Before we go forward, if we want to see the solid here, and as you can see, this is a twisted box, we just see the wireframe. The best way is to go to the params menu and use this brep to connect it. And before we go forward, if you want to also watch another tutorial about pufferfish plugin, we have talked about the tween surfaces in the surface and about the tween surface. You can watch it up here. I will put it. It's also related to the pufferfish plugin. So now you can see how easy it is. Let's just go to the display section and give it a custom preview so we can see that and easily understand what we are doing. So remember, this will control the U. This will control the number of divisions on the U. This will control the number of division in the V, which is basically the segments of the pipe. This will control the thickness, which is 0 is going to give it 0 thickness, and 1 is going to connect it to the center. So it's going to be something like that. And now let's just go to these three inputs, which I'm going to explain. Also, there is a parameter which is called normalized. You can see if it's a true, which is by default true, it's going to use the length of the curve based on that for the U parameter. That means if you give it a 0.5 here, it means the middle of the curve, and if you give it a 0.5 when it's false, it's going to be the domain middle. If you want to understand this, I'm going to show you just by a little example. Just assume that we have this curve. This is really important to understand that the domain of a curve is different than a length of a curve. So if I give this curve to this NURBS curve and go to the curve section, use this evaluate curve, reparameterize this and give it a 0.5. A 0.5 here doesn't mean this is the center of this curve. You can understand that by going to the analyzers and using the a tool called evaluate length. Again, I'm going to put this evaluate length here. We don't need to reparameterize this, but again, if we go to the normalized, you can see it says that if true, the length factor is normalized from 0 to 1. So I'm going to give this 0.5, and you can see that this is not the same. Let's just increase the range decimals. Okay, so you can see this. You can see that this point from the center of length by the center of the T or domain, it's really different. Okay, so remember the true and the false here defines that if you want to work with the length or with the domain of the curve parameters, which I prefer to put it on true. Okay, the diameter is really easy to understand. It's actually from the minimum and the maximum. We explained that for the diameter of this circle. The next step is the thickness. This thickness is overridden by the thing we have given here. Okay, so if you want to make an offset, let's just bring this another copy, and I'm going to control this thickness. Okay, let's talk about this one. When I decrease that, you can see when it comes down to a number, it's going to change according to this, but when I increase that, it's going to stay at a place even if I increase that. And that is because we have given a W domain which is controlling this thickness. So if you want to control that by an offset, you can also, let me show you again, if I decrease that to a number, it's going to affect the thickness, but after that it's going to be only affected by this one. So let's just delete this one and give it to the thickness. Again, for the rotation, this is also important. You can see that this is basically a twisted box. It's going to rotate those twisted box. So if I start from 0 and let's go to 360 degrees, maybe it's going to be wild, but you can see it. It's basically twisting those boxes alongside as it reaches the end of the curve. So you can see that we have twisted that 360 degrees as we reach the end. So that was the first step. Let's just increase the radius for the end and increase the numbers here so we can have more of them. Okay. If I bake this twisted box, you can see that these are the box and we have them here. Remember, you can also morph things in the twisted box. If you want to watch the twisted box, which we have talked about, and use the morph method, we can use the box morph. I will put that tutorial up here, and that is really great. For example, you can just draw something in 3D, maybe just a simple 3D model, and then put it in the box. Remember, you can always use the box morph to do that because this is a twisted box. Okay, the last step I want to take for this tutorial is to go to the Pufferfish plugin and go to the twisted box. Now what I want you to do is to thicken the twisted box to make it a little bit thicken. So this will be the last step. So let's just go to the thicken, give that to the twisted box. Again, if you want to see what's happened, you have to connect that B-rep to the thicken. And I'm going to explain that. That's going to make it a little bit time consuming to show it. So let's just turn this off and look at this. Okay, to produce this, there is parameters for the W. You can see it's from 0 is input twisted box and 1 is the thickness. What I want to do is again give this a number. So I'm going to say from 0, the shift key, and as you can see, as I move this, it's going to change the thickness. Let's go to one of these cells so you can see it. You can see that this is basically changing the thickness. Okay, so remember, give this from 0 to 1. That means completely from the corners to the center. But why do we see this here? This is because the thickness is again from 0 to 1. So now if I give this 1, you can see it's going to go to the center. So remember, if I change this number, it's going to offset that from 0 to 1. I usually use 0 to 1 to say it's complete, and then use the thickness to produce that thickness. Okay. The hollow part is going to, if I bake this, you can see that's going to produce this part and this part, and then we will have the frame. We want to delete these two things and only have the frame. So remember, there are many parts here, and there is also another input. Remove the center twisted box hollow. You can just give this a toggle based on true and false. It's going to delete the hollow center. Okay, you can see that this is going to give you a hollow center. So that's not really important. I'm going to delete that and put that onto the true. Now what I want to do is to pick up these things. So if you look at this, you can see each of those twisted boxes have 6 sections, and we can just select them with the sets list item. This is the first part, which is maybe the upper part. And what I want to do is to find the numbers what I want to pick. So I can go to the surface and find the volume of these parts. Okay, there's a problem here. We have to find the volume, so I'm going to connect that to a B-rep. This is the trick, and then find the volume. Okay, that will give you, then go to the display and select the point list. So remember, you can't always connect a twisted box to a volume. You have to give a B-rep before that. Let's just pick these numbers and find the numbers we have to delete. Okay, you can see that we need this first part. This is the 1 we need here. We need the 3, we need the 5, and let's just zoom up, and we need the 0. So if I look at these numbers, we have to get rid of the 2 and the 4 and have the rest. So it's 0, 1, 3, and 5. So we can just do that by selecting in the sets list item and give the index. So I'm going to set multiple integers. It's going to be 0, 1, 3, and 5. That's it. Let's turn these off. And before we can see them, we have to connect them to a brep. So that's easy. Connect them to a brep, and you can see that this is going to give you a thickness. If I bake that, I will have that in solids, and you can use that if you want to give that a thickness. So remember, you can change these numbers, maybe just increase this one, change the divisions, and so on. Okay. So that was a tutorial of how you can use this twisted box pipe variable. We also have another tutorial about pipe variable. I guess it's a really cool one. If you want to watch it, I will put it up here. Just check it out. That's also a great one. So you can always just produce this twisted box with thickness by this technique, and with on any curve you want to produce that. And finally, you will have those sections, and you can also join them if you want. Okay, thanks for watching. Remember to subscribe to our channel and like this video, because when you like our video, it's going to help us. And see you next time.